Test. No भाई.
Test. Check.
Okay. Let's get it
Yeah.
done. Okay. So, welcome back to day 34 of doing learning OpenUSD, and on our journey to get the OpenUSD certification from NVIDIA. Until now, we have covered 4 modules, as you can find them in the description and in the previous streams. The first 4 modules were setting the stage, scene description, blueprints, composition basics, and beyond the basics. We are doing the 5th module right now. And in the 5th module, basically learning how to create composition arcs in code and doing some hands-on exercises for the same. So we have basically completed the overview, pretty straightforward. The setup was pretty straightforward. We learned what is Prim composition, what are sublayers, had a very brief exercise on sublayers, and then did references and payloads yesterday. Um, did a very nice exercise on references and payloads. And then today we have basically went through the theory of what encapsulation is and what payloads are. Oh no, yeah, we have done payloads, but we have not done the exercises for payloads, and we have done encapsulation theory, and we have not done the exercises for encapsulations. So we're gonna just quickly go through the payloads one more time because we have already done that, and then just dive directly into the file and the live exercise. And the goal for today is gonna be to basically complete this part with the exercises, and then basically complete variance sets, inherits, and specializes. So I think these 2 submodules are gonna be the main task for today. And then basically gonna do at least 20 to 30 questions from the Udemy quiz, and then maybe go through the video a little bit more over here to see if they have some more questions. I do see they have some more questions over here. We did briefly go through the video, but yeah, the theoretical part is what we're gonna cover on our own time and not on the stream. But we're just going to reference these videos to see what kind of questions we should expect in the certification exam. So I think I should link this video in the description, this playlist in the description as well, right?
Yeah,
If
sure. It's gonna help.
okay, I'll do that in the future, or yeah, after the stream. So okay, let's get started on quickly going through payloads. Payloads are like references, but like the added, but with the added ability of being able to load and unload payloads on demand. Say you're only interested in inspecting, bro. Your mic is very sensitive. I can hear every crumble of that fucking thing that you just did.
Okay.
Okay. Payloads are like references. But with the added ability of being able to load and unload payload on demand, say you're only interested in inspecting a single city block in a city scene. First, you'd load the stage, the whole city with all payloads unloaded. The stage would load quickly because we have deferred the loading of most of the assets. Then you could navigate the scene hierarchy to find the city block or particularly assets you're interested in and load just those payloads. When you load the payloads, the data from these layers and any other layers composed on the other side of the payload are composed into the scene. So basically, what it's saying is that you basically have the whole city scene unloaded initially, and then you can load only the city, the buildings or the streets that you wanna, render by just loading it on the stage. So that's where payloads come in handy. So this allows you to be very quick in rendering these assets. Um, and it basically, makes it very easy to work on individual assets, I guess. And then, so by working this way, as it can say, you can see over here, you can save yourself load time, memory, and inter-exercise, since you are only loading and rendering a subset of the stage that you're interested in. And then payload composition arcs can be applied to same prim in a list editable way, just like references. Do you want to explain what this means to the people?
Which part are we talking about?
Payload composition arcs can be applied to the same prim in a list editable way, just like references.
So, in a list editable way means that you create an array or something similar kind of a data structure, and let's say you want to remove or add a payload. So, let's say there is a payload, assume x1, and there is another payload x2, right? But for some reason, you do not want to load the payload x2, so you can just pop the uh, payload out, and it won't be loaded at that point. So that's what that line infers to over here, that they're editable in a similar manner as well with the references that we did work on in our earlier exercises.
Okay. So payloads are weaker than references in the composition strength order, as we all know. LIV, RPS. Bro, I think we got a new subscriber.
Strikes again, new subscriber.
Oh no, I don't think it's that, because I heard the bell. Fucking,
Oh,
it's too loud. I don't know why. It's just fucking too loud. I don't know how to turn that off.
you can basically mute that tab. Like,
I have an infinite tab open for YouTube.
no, no, yeah, in that you can go on the top or right click on the tab on the top,
I did. Okay.
and then it won't budge you again.
Okay. And then, okay, so we know payloads are weaker than references in composition strength order, lever piece. On rare occasion, you may you choose to use this payload instead of reference to produce your desired composition order. So just a quick recap: lever piece are local opinions, inherits, variant sets, references, payloads, and then specializes. Now let's move quickly to working with payloads.
Yes.
Uh, so this is the exercise we're going to be looking at.
Yeah.
So let's first look at how payloads work using simple geometry. In Visual Studio Code terminal, run the following code to open the USD view. What do they want us to? Okay, so they want us to open the red cube again. I think I do have. Yeah. All right. Okay. And then what do they want us to do? Notice this is the same cube that we used with working with references. Close out the USD view and head back to what? Why did they want us to open it then? What the fuck? You're muted, bro, if you're saying something.
So for us to understand, like basically, to basically do a recap of references that we already worked on, maybe that's why.
Okay, and then check close out the blah blah blah. Open the following to view the USDA format. Okay, composition arcs, payloads. Simple example payload.usd. Let me copy this. Composition. Oh, okay. So this is what opens up for that part. Okay. And then it look like this: red cube 1, red cube 2, red cube 3. What are the some of the things you notice that are similar to references over here? So this is basically similar to references. We are prepending payload over here. So it's getting its properties from redcube.usd. So redcube.usd was this. So basically in redcube.usd, yeah, I'll open this over here. And then where is the redcube.usd? Shit. References. Simple example. Redcube.usd. Okay, so it's basically getting its properties from uh, doing prepend payload redcube.usda. So it basically got its properties from here, I guess. Any differences you should notice that the payload keyword instead of the references keyword, we can also see that payload is added similar to how references is added in USDA, where the only difference is the keyword. Next, run the following code in Visual Studio Code to open the USD view. Okay, payload simple.usda. Yes, we have this open. I guess. Yes. Uh-huh. You might be asking yourselves, how is this different from references? What's the benefit? Let's start by showing one of the differences between payload and references. Yes, this is my question exactly. What is the basic difference? It's doing the same thing. It's referencing the red cube to get properties for red cube 1, 2, 3.
Yeah.
So
So
let's.
I would say that the major difference is in references, you are always loading the file, whereas in payload, you can decide that whether do you want to load that file or not. That would be the major difference. If we go with the theoretical knowledge that OpenUSD provided with us earlier, but I don't know how does it affect the USD view at this point. Can we see that is there any option to offload a payload or to not basically not render that payload?
Oh, so here in composition, we can see payload like archetype, composition archetype, payload.
Yes.
Okay, and I think it's gonna tell us about the difference. What's the difference between reference and payload?
Okay.
So what were you asking?
I was saying that can you take a look into the USD view? The if do we have an option to offload a payload? Like because since payload we can offload a payload. Like if you do not want to render a payload, we can hide it or unload it in a manner. So does USD view allows us to do that?
We can deactivate it,
Oh,
I
we can
think.
deactivate it. Can you do deactivation once? Click.
Yeah, we can
Oh,
remove.
okay, okay. And then I think this is the thing that we cannot do
uh,
in references. Like, can you open references as well? Or
I think we should be able to do the same thing, and I think that's something different.
no, I think that because that is the main property and the major difference between rendering a payload and rendering a reference. Since references are already in a one-to-many relationship, so they will be loading all the time. Whereas a payload gives, because the way payload renders, it's really complex. It's going to render the whole file. So if you have a really complex USD scene, in that scenario, you select a payload for efficient loading, right? So you're
Mm-hmm.
in the room and trying to work on with the table and chairs, and you think there are 100 chairs, right?
Mm-hmm.
Offload all those chairs to render your scene without overloading your GPU out.
I see.
Yeah, so I think if we go back to rendering a reference, that option won't be available over there. Let's try that.
Okay, let me try that. I think it will be.
Okay, now right click on it and let's see if does it deactivate.
Yeah, it does.
Oh,
We can deactivate it.
okay, we can deactivate it, but is it
That's what I was telling you, bro. That this is not related to references or payload.
that should be enough? Because that was a theoretical knowledge and the theoretical base of references and payload, as I remember or recall.
Wait, bro. I think it's gonna show us in the documentation. Mhm. Okay. Oh, unload. There should be unload. We are right. On what? Red cube one. Oh, there is unload over here, but there is no unload over here. Okay, there is. Okay.
Reference.
Go. There is like above deactivate. There is unload.
Click on unload.
Yeah, it does the same thing.
So what is the difference between deactivating and unloading? Now that would be the major question, I would say.
So deactivating just removes it from the scene, and unloading has removed the properties. You see now there is no
Uh,
sublayers
oh,
under
okay.
cube. In red cube
What
2
I
there is
was-
q1.
Yes, this is what I was talking about.
Yeah. Okay. And then what will happen then? We unloaded it. In the tree view, we have the option to unload the prim. Okay, and then unload it. Okay, we did it. And then we can see that the red cube has vanished from the scene. Take note that when selecting unload, all the descendants from the payload are also not in the tree. Yeah, see, all the descendants from the payload are also not in the tree view.
We did saw that.
This is because the payload have the ability to load, compose all of the scene description targeted by payload or unload all the scene description recomposing all the prims beneath the payload, unloading them from the layer. What does this mean exactly?
This is because payloads have a ability to load, compose all of the scene. The same thing that I was talking about earlier, brother. Like
Hmm.
it has the ability to load all of the scene description targeted by the payload, or unload all their scene description and recomposing all prim beneath the payloaded prim. So basically, what it is saying over there is, let's say when once you unload a prim, it's going to recompose everything without loading the prim that was unloaded, and that's why we are not able to see the other scene descriptions when you have unloaded everything out.
Okay.
Yeah, that's what it is saying over there.
Uh, On the other hand, references are always composed and present on the stage. They cannot be unloaded.
Yes.
Oh, references cannot be. Yeah, that's what I was telling you. We can deactivate them, but we cannot unload them.
Yeah. So this is what I was looking for. Like there should be an option for that,
Yeah.
and we found it later on. That's fine.
Then right click on the root. and click unload.
Uh,
This will unload all the payloads that are composed on the stage. To load it back, right click on row root and select. Okay, let me try this. I'll just load this again and then right click on this and unload. Okay, so I unloaded it. So everything is gone.
yes.
Good. Mm-hmm. Okay. Okay. And then load it again. What? Oh, okay. She told me her name was Billie Jean and she got to sing. Okay. Now imagine that our scene has become too large and it's hard to see everything when it's fully loaded in the viewport. You can open the stage with all payloads unloaded and then load just what you need to work on the scene. Yes.
Ox. Yes.
Open this exercise in Visual Studio Code. Similarly, how we added references, we'll use get payloads and add payloads to add payloads to a prim. Okay. Okay. We want to override city.usda. We are doing geom set stage meters per unit, stage up axis, Y. Defining a stage at world. Paste over here. Okay. Uh-huh. Okay. I think it created a new file. City.usda. Yes. Copy path. Deactivate. And then USD view. And then let's see. Oh, okay. These are three buildings over here. And I'm guessing it's not loaded.
It's loaded. It's not. It's loaded. No, it's no. That's a reference. That's why it's not. It doesn't have that option, I guess. Right click on it. On this one. Yeah. Right click on this. Oh no, it has an option to unload. Is this a reference or payload?
This is payload.
Yeah. Okay.
And then what is it asking us to do? Save this in the terminal in the following code. Now let's open city.usd, blah blah. Yeah, we can see this exactly. As we see, each building here is actually payload. We can unload these via script as well. Interpreter to open a Python interpreter. Oh, there is a Python interpreter also. Oh, look at this. But it's too small. I cannot zoom in. Sorry. Oh. Mm. Okay. Uh-huh. So as we can see, each building here is actually a payload. We can unload these via script as well. Interpreter. We open the interpreter to open the Python interpreter. I add the following code into the interpreter and then press enter. Oh,
Oh, oh, we can open Python interpreter over here.
I did open it over here. See.
Oh, but the look shitty ass. Can you edit?
Yeah, that's where I'm gonna paste. So I paste this and hit enter.
Oh, damn. Nice.
So what did it do?
So it loaded the sudo root.
Unloaded the root.
What was sudo root again? Sudo root was
R-
what like the root
root.
file, right?
Yeah.
Can you print sudo? Can you print root above? Yeah. After that,
After this, right?
yeah, print enter print. Oh, it's not.
Oh no.
Just print root. Just print root over here. Let's see what does it returns. I think it's gonna give us the path. Maybe the do enter. Uh,
Oh yeah.
yeah, that's the it starts from over there. So basically, it's unloading everything from the root, like even the world as well, like even the main stage.
Mm-hmm. Bruh.
Why?
Oh fuck. I almost thought there was like a spaceship coming to get you. Bro, wear your AirPods. They have noise cancellation. What?
Yeah, there we go. Like it takes, I think, 30 seconds for my robot to dust off everything into the bin. Oh yeah,
Oh, I see.
I think now it's gonna go again. He's that's a hard working robot.
Okay, so now what does it want us to do? So this unloaded everything.
Yes.
As we can see, each building here is actually a payload. Yes. Okay. Done. 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 Let's say you want to only add one of the buildings back. Add the following code into the interpreter and press enter again. Uh, Okay. Yeah, we got one of the buildings back again. This means we can unload all payloads in the stage before opening the layer. This can save load time, especially for large scenes. Done. The exercise is done.
Whoa, whoa, whoa! That was quick.
Encapsulation.
Yes. Time for
So we,
encapsulation.
yeah, we'll quickly revise this. So basically, the idea of encapsulation over here is if there is a prim that is being referenced somewhere, um, and that prim has a property as well, um, but that
Opinions,
is
opinions, or
local opinion.
local opinions. That is a critical information.
Oh, bro, why do I get the fucking insane sleep wave at this time every day?
But because this is your body calling for sleep, like this is 11 p.m., right? That's your body is trying to get back to its normal sleeping schedule that you have been trying to fuck up. But that's fine.
Bluetooth connected. Oh, fuck me. Okay. Prims can be encapsulated or unencapsulated, which has implications for referencing and other composition arc. For referencing and other composition arcs, a prim is encapsulated when it is an ancestor of reference target prim. Reference target prim. When the prim is encapsulated, it will be referenced along with its ancestor. Okay. Let's take a look at how to see how it works. Hmm.
Brother, I think I just found subsidized cloud code tokens.
What? How?
I will send you the link.
Wow.
And it's not in China. That is the most important thing. That is the most important thing over here. That it is not something from China. So there is a VC that is selling some subsidized tokens. And
Uh-huh.
I want to take advantage of it somehow. But I just want to set up the whole thing. Yeah, how the fuck do I create that account?
I see, I see. Hmm.
Yeah. So now, yeah, I can reduce my cost.
Who dance and the flow?
That's fine.
Okay.
Okay, encapsulation,
Do
right?
yeah.
So, like, should we get started with the exercise, or how do you want to get?
Wait 1 second. Let me. So I'm just trying to understand this part first. Prim is encapsulated when it is an ancestor of the reference target prim. So what is the reference target prim over here? Target prim is.
So, reference target from could be anything. It could be X, Y, Z, whatever you want. That's what I would say. Like reference target frame is anything that you are trying to reference.
Mm-hmm. In OpenUSD, the reference target prim is the specific object inside an external USD file that you're pointing to and bringing in your current scene. Okay. A prim is encapsulated when it is an ancestor of the When a prim is encapsulated, it will be referenced along with its ancestor. Okay, let's look at the how it works. First, we look at an example fully encapsulated on the right. Blah blah blah. Right hand side, we can see blah blah blah. External references to encapsulated.usd. So encapsulated.usd is this default prim, meters per unit of axis, X form world, and then inside the world X form we have cube with preprint API schemas, material binding API, and then we have bold red material uh, layer stored under bold. Uh,
Bro, throw some water on your freaking face.
bruh.
Or just drink some water.
Come on, 1 second.
Don't go and sleep. I'm telling you, don't.
No, bro, I'm not going and sleeping, bitch.
Yeah. Fuck you. Last time you fucking slept in the live stream. Fuck you. And then you're like, bro, oh, let's do more. And then you're gonna fuck up your sleep schedule more.
It's already fucked, bro.
So that's what I'm saying.
There's no more, and you cannot save it anymore.
Get your shit together. You
I
just
cannot save my sleep schedule anymore. I've given up.
no, bro.
I'm just grabbing some
Bad
nuts.
sleep. A bad sleep can fuck up your whole week. Specifically for me, yeah, it does.
But the thing is, when I sleep very well. Like I have deep sleep, so whenever I sleep, I just get like full recovery
Nice.
because I sleep for like 7, 8, 9 hours.
Amazing. Amazing, brother.
But just in between office. Sorry, Corey, if you're watching.
It's gonna show you what you are sorry for tomorrow or in the upcoming weeks. If you do this thing, you're like, all right, brother. I see what you're doing.
Now I get it why you're working from home so much. Your bitch ass is sleeping. Okay. Hmm. Yeah, let me. I got some nuts, so that I am alive.
Makes sense.
Okay. Yeah. So let's take a look at how it works. Blah blah blah. Encapsulated.usd. On the right side, we can see we are making an external reference to encapsulated.usd. But in this USD, we are not making any ref. Oh, over here, encapsulated.usd. It's prepend references, and then this is the reference. So define encapsulated, and then prepend references is encapsulated.
Mm-hmm.
Here we can see that the contents of the reference include a cube that has binding to a red material. Cube, prepend API schemas, material binding API, relative part, material binding, world, and slash red material. Okay. Bind material as weaker than descendants. What? This is metadata, right? No.
What?
Bind material as weaker than descendants.
No, that's not metadata, I guess. That's something else. That's namespacing. Like that is
Okay.
something from the OpenUSD. Metadata won't be over here. Metadata is hidden. You have to call metadata.
Oh, I got it. So over here we are defining the material as red material. Okay, and then here we can see that the contents reference include the cube that has a binding to red material. While when referencing encapsulated.usd over here, we are going to see that everything will be brought over that is contained under the XForm world. So okay, because it is the default prim, so everything under the XForm world will be incorporated when encapsulated. When referenced, it will be encapsulated in here. And then for the unencapsulated part, this is referencing the unencapsulated.usda. But over here, since the default prim is world and the scope looks are out of the material, out of the world,
Mm-hmm.
and we are defining the red material inside the scopes. So only this part is going to get referenced, which is the cube
Yeah.
uh,
That material
prim.
part won't be referenced.
Yeah, materials part won't be referenced. Yeah, I get it now completely.
Mm-hmm.
Bro,
So
these nuts are amazing.
these nuts. I was gonna say, is it because of the depth scope looks, or is it because the way, like, or the way we defined it in earlier in our code? What do you think? What would make it? I think let's go to the experiment and then we can take a look over there to see. Yeah.
Yeah. Okay. First, we'll take a look. Okay, let's take a look at two examples. One showing proper encapsulation, and another as improper encapsulation. First, we'll take a look at a layer with good encapsulation in Visual Studio Code. Terminal run the following. What is it? Mm, mm, mm. She told me her name was Billie Jean, and she caused the scene. Morning. Oh, okay.
What?
So when we perform this interpret interpreter Python execution,
Uh-huh.
it's gonna show us the logs over here.
Oh, wait, dude. I do remember it. I'll be back. I will take a leak.
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 Her with Billie Jean, and she got the scene. She told me her name was Billie Jean. She says I am the one. But it is the mine. Betraying.
All right. What do we have?
Mm-hmm. Okay. Once the file opens in USD view, expand the root and its children in the tree view hierarchy in the top left corner. Okay. Yeah. So root, world, cube, red material, and shader. So okay. So we can see the red material is inside world.
Oh, interesting.
You see. You see slash world slash red material.
Slash.
Slash world slash
Okay.
over here.
Uh-huh.
Slash world slash red material
And
root
then
archetype root
okay.
encapsulated dot good USD.
So yeah.
And then why is it good? What are the clues to show that it is good encapsulation? We can see
Oh,
in the tree that all prims are encapsulated under the default prim world. So this is under. But now let's open the bad unencapsulated bad.
mm-hmm. You're gonna run the bad one. The
Yeah.
bad one.
Okay. So
Oh,
now here very clearly
okay. Okay.
we can see
So you are saying that it's because of the file structure we are getting it like that.
file structure, not the file structure, bro. The
Like in the
prim
file. No,
prim hierarchy.
no. I'm like that's what I meant. Like in the file, the way the file was structured, so
Hmm.
the look was in a different depth, and the red material.
Yeah, exactly. Yeah, yeah,
Why it's not encap. So the define encapsulated and define uncapsulated. That is
yeah.
that doesn't matter over here. You're saying
What?
like
What are you asking?
if you go back into the code, we are gonna define uh, open the encapsulated USD.
Yeah, 1 second. Unencapsulated or
Yeah, right.
uh,
So
this is unencapsulated over here.
on
So
the
over here, look at this. So default prim is world.
mm-hmm,
Okay, let's look at this first. This is the good encapsulated one.
mm-hmm,
So this is the default prim world. Okay, and everything like cube prim is defined underworld,
mm-hmm,
and then material is also defined underworld.
mm-hmm.
So when we open this in USD view, we can see that the red material has the path is slash world slash red material.
Mm-hmm.
So when we reference encapsulated good in a file or in a different USDA file, it's going to get all the properties of this world, which is the cube, as well as the red color. Okay. But when we reference unencapsulated bad.usda in another file, right, we are
Mm-hmm.
just going to get the cube. Why? Why not scope? Because the default prim over here is world, and hence only the default prim properties are going to get referenced in the prim where in the file where we are referencing this file unencapsulated bad.
Uh,
It's not gonna take. I think to reference this particular thing, we have to do something else, which I think we are going to learn in the
okay.
future. Yeah,
So all in all, it's
that's
all about the the way the prim was structured in the USD,
yeah,
right? All right.
yeah,
That
yeah,
was the only doubt.
yeah. So we opened the WAD encapsulation. Over here, we can see the root and children in the hierarchy on the top left. So looks are different. Why is it bad? What are the clues? Blah blah blah. As you can see here, our material sits outside world under looks. A key part of this asset is not included under default prim world. Let's see what happens now when both layers are referenced into another layer. In the terminal, run the following code. So now they want us to run references encapsulation.usd. This one. USD VU. Okay. You see over here.
Wait, I was taking a look at that. Wait, fuck. Let me
What
mute.
happened? So over here, if I click on world and then encapsulated good, because we have referenced this in the from that file that we're looking at, cube, and then red material. So only this encapsulated part has propagated the red color over here. And although the unencapsulated reference is also like the cube is also red over there, but we are not able to get that red color material code, USDA code over here when we reference it because it is not part of that default prim in that file. I think this is what they're going to tell us. Hmm. Trailer. Okay. What can we infer about the scene? As we can see, only one cube has both the mesh and the material brought over, even though the blah, blah, blah. An encapsulated layer has a material. It was not brought over when referenced. This is because the material was not encapsulated within world, and our references is targeting world as a source frame. Yeah, look at this. Hmm. Mhm. Bro, why do you forget that you're mute?
Oh yeah. So this is because we had the other files, other prims in a different prim, right? So like if you have the prim in a different prim, you won't be able to load it. That's
Hmm.
that's encapsulation. And if you have all the files in the same prim, that's encapsulation, right?
Default
The
prim.
default,
Yeah,
that's encapsulation. Am I correct?
yeah, yeah,
Perfect. That clears up
yeah,
our basics.
yeah. Variance sets. Finally, god damn.
All right. Variant sets. So variance set allows you to define variation or alternative representation of same dataset that can be switched at runtime. The most common use case for this is to be able to define a singular asset while enabling multiple representation of the asset. Okay, that is you
The
can.
most common use case of this is to able to define a singular asset while enabling multiple representations of an asset.
Okay.
Oh.
So yeah, we are loading a single asset file, but in that
Hmm.
asset file, you can have multiple variation of that same asset, right?
Hmm.
So, for example, a character that has multiple outfits could be authored with a variant set that controls which outfit should be used for a given shot or scenario. This greatly reduces the complexity of managing such a character. Without a mechanism like variant set, you would need to track the character and clothing separately. Okay, hold on. This greatly reduces the complexity of managing such a character without a mechanism like variant sets. You would need to track the character and clothing separately. Okay. Okay, without that, right? And assemble them on demand whenever a particular character and outfit combination is needed. Okay, so they are trying to understand, tell us the whole analogy of variance sets. Why is it important, and what will happen if we do not have variance sets? So over here, it's saying that, for example, you have a character with multiple, let's say, look. So if you do not have variants, then each and everything has to be rendered all the time. Like, let's say if you want to just change the hair color, the whole the whole scene will be decomposed, right?
Mm.
But if you have a variant, then only that asset file will be recomposed, or basically you will just pick up option from it. The first variant would be hair color, the color of the hair color will change, and only that asset file will be reloaded. This showcases the non-destructive workflow of OpenUSD again over here.
Hmm. Variant sets allow you to define variations or alternative representations of the same data set that can be switched at runtime. The most common use case for this is to be able to define a singular asset while enabling multiple representation of that asset. For example, a character that has multiple outfits could be authored. Yeah, I think we saw a question about this as well. Multiple outfits could be authored with a variant set that controls which outfit should be used for a given shot or scenario. This greatly reduces the complexity of managing such a character without a mechanism like variant sets. You would need to track the character and clothing separately and assemble them on demand wherever a particular character and outfit combination is needed. I think a lot of game development studios are also going to use OpenUSD, right?
Yeah, Apple is also going to use OpenUSD. I saw on Apple developers keynote.
Really?
Yeah,
Huh. Is the next job at Apple? Maybe.
I don't know.
A variant set serves as a controller of variations. We call the variants in OpenUSD. Only opinions of the selected variant are composed on the stage. A variant set serves as a controller of variations. So a variant set is a set of variants, right? Like set of variations.
Yes,
So it serves as a controller of variations. So variant set decides what version or what variation is going to be composed.
yes,
We call the variations variants, like mutants, variants, mark, invincible variants. In OpenUSD, only opinions of the selected variant are composed on the stage. Huh. Composed on the stage. It's up to the author to decide what type of variations a variant set controls. It's up to the author to decide what type of variations a variant set controls. There are no rules for what a variant set can add or modify, but it is helpful to limit the scope of variant set to that. The results are more predictable when users are blindly selecting a variant. Uh, What type of variant set controls? There are no rules for variant. I don't want to order that. Limit the scope of variant set so that the results are more predictable. Okay, I get it. Hmm. So over here, let's see the example real quick. The green cube material. Overshader 010. Blue is over cube material overshader. Color F 3F. Inputs diffuse color 001. Okay. Mm, mm, mm. A variance head is added to the prim, and its variants can manipulate the prim and any of its descendants. Let's go through a few things a variant can do within its hierarchy. Variants can sparsely override properties on the prim or descendant prim.
Okay, variant color we have blue and then green. It's like a JSON
Yeah,
object. Then we have over. We are using
it's
over
like a what? What
JSON
did you say? It's
JSON object.
JSON. Yeah,
Yeah.
yeah.
We have like over and then again over and then. But why are we using over? So is it necessary to use over in variants?
I don't know.
Okay, well, I think
I
you
think yes, because we are not defining a prim, right? We're just defining a what do
over
you
is
say,
for
a
overriding,
variation,
right?
huh?
Over is for overriding, right?
Yeah. So like whenever you select a particular variant,
Mm-hmm.
you're going to override the local opinion.
Hmm.
I think that's why it uses over. But like we can definitely, I think it's going to tell us about it. In this example, we can set there are two variants that override the diffuse color of the cube material. Bitch ass.
What?
Don't look at your phone. Look at this.
Dude,
This is answering your
I
question.
got a really important message from Cloudflare regarding our site. So I was just taking a look at that.
Uh,
So in
so
this,
it's saying,
yeah.
yeah, look at this. In this example, we can see that there are two variants that override the diffuse color.
Oh, okay, okay. That's why we are using override
Uh,
because the local opinion
yeah,
says the color should be that. Wait, what is? Oh, now it makes sense. And one
yeah.
variant overriding the color to be blue.
One variant is overriding the color to be blue and the other to green.
Makes
So
sense.
over.
Makes sense.
Variants can define new descendant prims. New descendant prims.
Yes.
Oh, so variants equal to over here. Def x form cube stack, and then variants string count one. Prepend variant set equal to count, and then close bracket, and then they're creating variant set count.
With variant string count equal to one. So that's a default variant. Okay. And then we are gonna prepend variant sets that is gonna be count. Oh, okay, okay. Oh, okay.
So they are okay. So this will be referenced before this kicks in.
Yes. So we are first defining what the variant is. Similarly,
Uh-huh.
we are going to define the sets, and based on the sets definition we have, it should not have duplicates or they should be immutable, right? In Python. So I think this is what we follow over here as well. And now we are defining them one, and then the variant name, but we are using def over here for some reason. Why?
Hmm.
And then we have two. Oh, okay. Then we have multiple prims inside that other variant. Oh, okay, okay. So we can have multiple descendants. That's what it is saying over here. So
So
what?
when count is one, we'll have def cube one and
Oh,
only one cube. When
okay.
variant set count is two, we are gonna have two cubes.
Yes,
I see.
makes complete sense.
The dots are connecting now.
Here we have two variants where one variant and one cube, and the other is defines two cubes. Variant can
Mhm.
be used to author new composition.
Arcs
Add,
that
add
would only exist within that variant.
Okay, wait, let's go in. Oh, okay, okay. So you can define references inside. Wait,
Okay. Variant set color equals to blue. So when the variant set is blue, override cube material references materials.usd looks blue. Okay, materials.usd. Where was it? Oh, okay, okay. Got it. So, variant set color blue over cube references are. Yes, yeah, it is doing the same thing, right? We can author new composition now that would only exist in the variant. For example, one variant can reference a blue material from a materials layer. Another variant can reference a green material from the same layer. Okay. Basically, when there is going to be a def look or scope look, and it's gonna have two different, what do you say, materials, one blue, one green. So particular variant can reference a particular color from that look, and so okay, got it. When and why do you use them? Blue, green. You could author a single variant set on an asset to control a single set of options, like different materials on cube in the image above. Different materials on the cube in the image above. Okay. Or you could create multiple variant sets for different purposes that can be controlled separately to produce many different combinations. And then a common pattern is to author geometric and shading variant sets. Geometric variant sets control changes in an asset's geometry, and shading variants control changes in an asset's materials. I see. Oh, somebody in the chat is telling us good luck. Treasure Rose 632. Thank you, bro. Treasure Rose. Okay. Geometric variant sets control changes in an asset. Yeah. Oh, goddamn. Let's consider another example. If you want to have a character with two geometry options, where the character is wearing a hat. Uh, hmm. That's gonna. If you wanted to have a character with two geometric options, where character is wearing a hat or no hat, two material options of dry and wet. Dry and wet. Out of everything, they chose dry and wet. You could produce four different combinations. Keep in mind that combinations are not free. You have to author relevant data for each combination, and it is easy to run into two risks. It is easy to get carried away with adding too many variant sets and creating variant combinations that will. What?
What do you mean by author? Like, you need to have separate metadata for each of them? That's
This part.
yeah.
Where? What part are you asking?
Like keeping
You have to author relevant data, right?
yeah. So that
So
if
basically,
the
for
metadata,
each variation over here, like for each variation, you have to define variants, right? So like you cannot keep creating variant sets without actually defining the variation. That's what it means over here. You have to author relevant data for each combination, and it is easy to run into two risks. Easy to get carried away with adding too many variant sets and creating variant combinations that will never be used, like a wet character without a hat. You may choose to not author data for all combinations, exactly not author data, but can create bad user experience when end users try to use non-functional combinations. So basically, in a game, you basically modify your character, but you don't have the USDA code for the type of modifications you're offering. Considerations for variant design: when designing variant sets, it's helpful to understand the performance characteristics of different kinds of variations. Not all variant switches are equal in terms of computational cost. If you're looking to maintain real time performance when switching variants, this is an important design decision. What does this mean? It is helpful to understand the performance characteristics of different kind of variations. Not all variant switches are equally in terms of computational cost. Yes, if you're looking for the main to maintain real time performance when switching variants, this is an important design decision. So we have to keep in mind lightweight stuff to be created. So do you know how this relates to our InstruX
Which part?
pipeline?
This part?
Variant sets, just variant sets in general.
I think because we will have multiple type of scenarios over there for our
Hmm.
robots to take care of, and multiple
Yeah,
simulation environment. Maybe we can have a cone object, and then we can change the cone object size, color, weight depending upon.
yeah, yeah,
So
yeah.
we can have let's go ahead with an Amazon box. So we can have
Hmm.
an Amazon box with multiple variant sets. For example, the weight of the box could be 10 kilos, or the weight of the box could be 5 kilos, depending upon the scenario. And but the dimensions.
Hmm.
So this is where multiple variants can kick in and come in, right?
Hmm. I see. Okay. So some variant options are relatively fast because they only affect value resolution. These include changing attribute values, for example, switching a color from red to blue, or changing numeric parameter, changing visibility, hiding or showing geometry without affecting composition. These operations are lightweight because USD doesn't need to rebuild the composed scene structure. The stage's composition index remains the same, and only the final resolved value changes. Think of this as changing the settings on existing scene element. Okay, composition index is the index that we know. An index is the composition structure that determines how a frame is constructed on from multiple frame specs. Heavyweight variant switches. Other variant operations require more computational work because they change the composition of structure itself. Changing reference paths, swapping which layer files are brought into the scene, changing activation opinions, activating or deactivating prims, which affect what gets composed. These operations are more expensive because USD needs to rebuild parts of its composition index. When a variant set changes, what gets referenced or which prims are active, USD must recompute the composed scene structure, not just resolve different values. Understanding this distinction can help you design more efficient variant sets. For example, damn, my leg, bro, fuck cramps.
I'm also getting cramps for some reason.
I hit legs yesterday.
This
That's why.
system can help you define more efficient variant sets. For example, if you need users to frequently toggle between options, consider using attribute and overrides. So this is what I was talking about earlier, like for the Amazon box. Let's say you have
Yeah,
different attributes. One of the attribute could be the size of the box, but the color stays
yeah.
the same. And there could be different kind of things, right? Or visibility changes when possible. The box gets hidden in a minute,
Mm-hmm.
right? Reserve structural changes like swapping references or changing activation for less frequent switches. When go up, when the flexibility is worth the additional cost. The difference between the note that I think the note is really important. The difference between
Wait,
visibility.
wait, wait. What is this? Understanding this distinction can help you. Yeah, okay. For example, if you need users frequently toggle between options, consider using attribute overrides or visibility changes when possible. Reserve structural changes like swapping references or changing activation for less frequent switches of when the flexibility is worth the additional cost. Okay, got it. We are not getting too many views today. It's only 38 views. Okay, note. The difference between visibility and activation illustrates this well. Visibility is purely rendering concept that doesn't affect composition, while activation determines whether frames are composed onto the stage at all. This is why changing visibility is faster than changing the activation when switching variants. Switching variants, yes. Okay, variant sets was pretty easy. I got everything. Like I understood everything.
Nice. So what was the last note that it was saying? What is the last?
Last note was basically that basically if you are creating two variants with like one
Oh,
for visibility and activation, so you should do it for visibility because it is
much faster.
much faster and easier and computationally less costly rather than doing the activation because it takes like in switching variants if you are doing activation it's gonna make difference in the layers that gets composed. So visibility is an attribute, so you have to keep that in mind while creating variant sets
Mm,
basically.
makes sense.
Tum, 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 tum. Okay, variant sets is complete now. Exercise.
Exercise working with variant sets. All right.
I think it should be easy because we understood everything over here. Now, composition arc, variant set, simple example, variant sets. What? Yeah. Okay. So it has rendered a cube again. What does it want us to do? Select the metadata tab. Oh, metadata. For what? In the tree, select world. Okay. So color variant. Oh, look at this. Blue. But blue is not present. Green. Green is there and red is there. So what is blue? Blue is not present. Oh, blue is present. But why is it not able to do it over here? Mm-hmm. Yeah. So you can basically choose different variants over here. Oh, deselect the world. Ah, I see. So you can choose different variations. So basically, okay, so I think world is referencing variant. Look at this variant set simple.usd.
Mm-hmm.
So they have created, okay. And then in metadata, when I do red, composition is variant set simple variant slash world color equals to red. So if we go back to the file, actual file, where is it? Variant sets, variant set, exercise. No, not exercise. Practical, simple example. Variant set simple. Uh-huh. So now variant set color blue. Okay, so here they have defined variant set color blue, green, red over here. Bro, I'm excited
Nice.
because now we have understood like what the code is, how the code works. Now we'll be able to, do it with Claude code so easily.
Mm-hmm.
Like it's going to be amazing.
Nice.
And I know, and then we'll know what agents to create for what.
Fuck me.
Like for payloads, we have to create agents. For variant sets, we have to create agents or something like that.
Mm-hmm.
We'll now understand exactly what the agents are going to be useful for.
Mm-hmm.
Okay. So we did the you can turn off highlights section. Better to see better see the material change when selecting different variants in order to turn off the highlight section or to display selection highlighting never. Display selection highlighting now. What does this do? Mm-hmm. So what exactly is changing when we select the blue as our color variant? Okay. In the tree view, select shader from there and we can see the input diffuse color is 001 representing the color blue. Shader, let me world blue shader and the color input diffuse color is 001 over here. And then layer stack path is slash world color blue use cube material shade input diffuse color 001 composition variant set. Okay, so this is basically that. Now change the color to red in the data select the blah 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 on the drop down. Okay, metadata world red and then shader values are 100 input diffuse color 100 value. Then in the again what is it? 100. Okay, the color variant is set separately overriding color variant set is sparsely overriding the input diffuse color property. Now let's see how variant set can define new prims. Okay, so we have completed that and now it wants us to run this variant sets define.
Variant sets define basic creating composition arc. Variant sets exercise. Alright, alright. So what we have done till now. We're gonna select a highlighting only when paused. Blah blah blah. Okay, so what is exactly when? Mhm. Okay, okay, makes sense. Diffuse color. Mm-hmm.
World metadata, no cube stack, 1, 3. Oh, okay.
Count, or you're changing the count now?
Yeah,
Okay. So why is it getting stacked? Because of the y-axis.
I don't know about
We
that.
have somewhere y-axis set as the up-axis. Can we change the y to z and see if it does that? If we go back into the USD file,
Let's first complete what they're asking and then we'll do that. Okay, so we can select the variant sets. Okay, cube stack. Okay. Mm, yeah, we did this. What did you notice happening? Can you see the changes in the tree view? In this example, we're showing how one can define prims using variant sets. Use case for utilizing various sizes of the shelf or containing that are defining a new row, blah blah blah. What were you asking? Can we do the
like
uh
access to z instead of y for the where we were creating. Yes, go up and this. Yes, yeah, do z capital Z, and let's see what it does.
I think it's gonna
Okay, now add the count to 2 or 3 or something.
okay, yeah, it's
Yes, sir.
doing it over there.
Yeah,
Three, yes, it's going backwards, like that side,
yeah.
inside the
But I think
yeah,
it's going backward because that's how you render it. So like if you rotate it, rotate. Yeah, and do one now. Go back and do one. Yes,
like this.
yes,
Yeah,
and then do one.
yeah,
Oh, now it does. Now do two. It's gonna do.
yeah, yeah.
So this that is the front facing side. Z axis should always be like this. That's why it should render like that.
Z-axis is both inside and towards us as well.
But the way it is stacking, right? It should be towards us, right, or not?
I don't know. I'm not, and what about x-axis then?
No,
It's not.
no, up axis that's up axis. It's gonna default to Y. That is the fallback value in USD.
Okay, that is done. So now what is the okay? We have done that, and now it's asking individual run the blah blah blah. Okay, so new file variant set add aux. I'm back. I'm back. I'm back. I'm back. I'm back. Metadata. Yeah, it's doing the same thing. What?
So so based on this, variance data is stored under metadata, right?
Metadata?
Yeah, like because you're trying to do the changes in the metadata right over there.
I don't think so.
Mm,
What metadata?
go back. Metadata, right? The value, the tab metadata in the USD view.
Oh, yeah, 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 yeah. Over here, yes.
So the variant values are authored into the metadata. Yeah, that. So that means that was the correct statement over there. Like now it defines what they said earlier.
Let me see what it's saying over here first. Select the metadata tab in the tree view. Call the color variant. Try selecting different options on the drop down. At first, this appears to be similar to our first example. However, the material is being composed through a reference this time. Oh, I see. So layer stack, composition. No, but is it? It's not. It's not reference. It's variant. Oh, this is. Bro, this is the layer name is missing over here. Why? Cube material. Oh, yeah. Yes. Okay. Material.usd. Composition. Material.usd reference. Okay. So in variations, in variants,
Mm-hmm.
you can also add different references. So like for example, in first variant,
But
you can reference the different USDF file,
mhm.
and in different variants that you can
But
reference
we
the
have
different.
descendants. That
Mhm.
that was in the theory earlier, right?
Mhm. Okay. Hmm. Ah. To see where the material is being composed from, select your material and review in the okay, so we can see it's from materials.usd. In the metadata tab, notice that the reference is coming from materials.usd and targeting the looks red prim as a source. If you selected a different color from the drop down, you might see looks slash green or looks slash blue. Yes, instead. And then metadata references, SD reference, list, OP, explicit items, blah, blah, blah. Okay, let me see. Layer stack, metadata, references. Bro, why can I not zoom in this shit? It's so small. The text is so small over here. Okay. Try going back to the world in tree view and change the selector how that changes the reference for cube material. Change selector variant. Oh, okay. World metadata green cube material references looks green or okay slash look slash green. Open the following exercises. Variant set exercise pi. Mhm. What about us? Da-da-da-da-da. What about us? Oh, ho, ho, ho. Okay. Toggle lights. If on intensity equal to 100 emissive color 111 else intensity equal to 0 emissive color 000. Lights go blah 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 blah. Okay. Okay. First, let's add new empty variant set. Add the following code in the part one block. So we're just gonna define a Python file that creates a USD file that is creating some variants.
Mm-hmm.
B set equal to
So till now, I haven't seen create variant, create variant set. Oh, there is only
yeah
something add variant set or add variant.
yeah. This was flagged by
Add
me.
variant set. Oh, and add variant.
On and off.
Oh, light. Oh, okay, 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 okay. Makes sense now. It makes sense. Okay, we are adding a set and then we are adding variant inside the set. Okay, okay.
Oh shit. Subvariant set.
Yes, sir.
I don't know how I'll play football tomorrow. Fuck.
With all your energy.
Uh,
Oh.
and then I have to spar on Thursday again.
Mm-hmm.
It's gonna be insane. Oh shit. Uh, 6 to 7. I have a game from 6 to 7 tomorrow, and then 7 o'clock I'll go to the gym for massage and sauna, and then I think I'll be home by 8:30 tomorrow.
Sweet.
Sweet, sweet. Wonder, wonder people, if you're watching, fuck you. You raised prices. I'm gonna switch to factor meals now. You motherfuckers raised prices. Okay, I think if we run Python over here, what about us? What about us? What about us? VSET is not defined. Oh, she told me her name was Billie Jean and she got to see. So what are we doing? We are defining we said USD dot variant set root dot get variant sets dot add variant sets lights add variants add variant on add variant off. So we are creating the variant set using the add variant set method and get variant set dot get variant set and dot add variant set. And then let's define what each variant is. First will be on. We'll call the function toggle light, which sets the intensity and emissive color of the light and material respectively. Add the following code into the part 2 block. So we set dot set variant selection as on with we set dot get variant edit context toggle lights true. So okay, so whenever the set variant selection is on, the we set dot get variant edit context toggle light is true. We will repeat this for the off variant. Add the following code into the part 3 code block. Okay. But why have they not defined vset over here? She told me her name was Billie Jean and she got to sing.
We said
Save the file.
get variants. Okay, okay. What are you saying? Set variant selection of we said dot get variant edit context. Oh, these are all the Python
Oh,
APIs.
okay. So it's done. It worked. And what was the street lamp dbl.usd copy path deactivate USD new brother.
Yes,
Your business is just texting people.
yes.
Oh, now this is a street lamp that we have created. And then I think if we go to light
What are the
and
variants that we have?
metadata, hmm, where is the on and off metadata, bro? Default mode. Hmm. Shitting.
Not sharing, canceling, canceling,
Bot canceling.
canceling a subscription that I was charged that I had already canceled, brother, on Apple.
I'm still paying for Apple Music every month. That I don't even use.
Then cancel it, brother.
Yeah. Every time I think I will do it, I never do it. And then next month comes and again I see a charge of $13.
Dude, that's on you.
I know. She told me her name was Billie Jean. She got the scene. But where is the fucking metadata? In the terminal, run the following code. We ran Python. World light. Why are we not getting the fucking? DBL reset. Oh, my bad. I ran the wrong. Shit. Shit. Oh, it is vset.usda, right? Yeah. Metadata now word. Yes, look at this. On. That is so fucking weak. Oh, look at this.
Oh,
on,
damn.
off, on
That's
and off.
variance sets for you guys. That's variance sets.
Yeah, bro.
Damn, that's so dope. I think we might be getting views now. Take a look.
No, only one. Mm, only 49 views today. I don't know. Bro, I think we get more views on the weekend.
Nice.
I think that's because people have more free time, I guess.
Mm.
So Billie Jean is not my lover. She's just a girl who thinks that I am the one. Okay, variant set is also complete. Inherit and specialize. Inherits and
So we are just gonna
specializes.
do theory for this, not the.
Not the what experiments.
Yeah.
I think we should do quiz now. I think we can do the theory tomorrow in the morning. Oh, not in the morning. Tomorrow.
Yeah.
And yeah, we can
Do the
take
quiz.
this.
Yeah, let's focus on the quiz then.
Okay, so just to recap, we just have these two submodules left for this one now.
Yeah.
Oh, we are getting close, bro. We are getting close. We are almost I don't I think now we can say I think we are 50% done with.
No, with what? No, dude. We are still in composition arcs. We are not even. We haven't seen the data pipeline and whole the other things. We are still in the composition arc.
But this is like still 50%, bro. I think that's the other 50%.
No, dude. I don't think so.
Okay, let's see an asset structure principle.
We would be 23%.
That is weightage. That is weightage of the fucking
Yes,
paper.
yes. So, like, I will go with the certification, right? Like, if the certification says that 23% is for.
Bro, no, you are such a
Dude,
bitch ass
what
motherfucker.
is
Look at
that?
this. Shut up, shut up, shut up, shut up.
What is
Okay,
content
wait.
aggregation over here? Tell me, what is content aggregation?
Yeah, I'm not saying we have done content aggregation, but
Mhm.
we have done. Okay, what is this? Export, import, interchange data. Did we do data exchange? We did data exchange, right?
No, dude, not yet. Mapping documents,
Debugging.
custom importers, exporter script for interchange of data with OpenUSD. We have not done that. Customizing USD, we have not worked with any plugin yet. Content aggregation, build modular reusable components. Have you done that? No. We have
So
only.
we have not even done 15%, then that's what you wanna say.
Yes, brother. Like we are at, once we complete the composition arc and everything, then we will be at 23%.
So bro, I think yeah, 26th, right? Exactly 1 month.
Yes.
You're saying we took 1 month to do 20, not even 20%.
Yes.
And then you are saying in the next 1 month we are gonna do the rest of the
Yes. Oh,
70.
that's the power of compounding. That's the power of
Okay.
compounding because we are going to change our strategy. You know what I mean?
What strategy? What are you gonna change?
The thing that we did today.
Uh, okay. Yeah. So let me see asset structure and principles. Principle of asset structure. Okay. Work streams. Developing data exchange. Okay. Asset modularity and instancing. What is instancing? What is asset modularity? Scene graph instancing. Scene graph instances. Authoring point. Okay. Okay, you want to do the quiz now?
Yeah.
US Udemy.
Yes. Let's do
But
it.
what if it is inaccurate?
Then we are gonna verify each and every question. Then what else?
Bruh. Okay. You are working on large scene and want to improve loading times. Which OpenUSD features would be the most effective by deferring loading of non-essential
Notes.
payloads? How can you query the value of USD attribute using Python?
Get method.
How can you query the
You
value?
you have to use the get method to query.
Get method on what? On USD attribute object. I think. Hmm. I don't know about this one. I don't remember this one.
Which one?
Get method on USD attribute object.
Dude, you're this is one of the basics, and you're saying you have completed 50%, right? Wow.
Fuck you,
What an achievement, brother. What an
bro.
achievement.
Some
What an achievement, brother. You're saying that you have
the
completed
fuck.
50% and you're not able to remember this shit.
Okay, you're saying A, right? You're
Yeah.
saying A, right?
Yes.
Get method on USD. Oh yes, USD attribute. Okay, my bad. Yes, this is the correct way to query attribute values. Which of the following is valid composition archetype in OpenUSD? Inherit.
Which always, yeah, inherit.
How can you create a new attribute on USD Prim using Python? Using create attribute method.
Yes.
You are designing a USD based system for managing asset metadata.
Mm.
You need to store custom metadata about each asset, such as its author creation date, license information, which USD feature is most suitable for storing this metadata. Custom.
Variant sets.
Oh, I don't think so. Not variant sets.
Gotta be variant sets only. We just read it, dude. We just read it.
But asset metadata.
Yes,
This is not.
yes, brother. Yes.
You are designing USD based. Wait. USD based systems for managing asset metadata. You need to store custom metadata about each asset as its author creation date and license information. No, I don't think it's gonna be variant sets.
Then payload composition would be the closest. Apart from it, nothing suits or nothing fits.
Payload composition, yeah. I think payload composition would be the right answer.
Okay.
Because we are just storing the metadata. Yeah, payload composition. Oh, custom USD attributes.
Let's do a Google search.
Custom data, yeah, it's right. Custom prim metadata. Yeah, I told you, bro, it's not variant sets.
And not neither payload composition.
Yeah, okay, but variant set was definitely not the answer.
Hmm.
The most suitable USD feature for storing asset level metadata is custom prim metadata using custom data dictionary. Custom USD attribute. Dictionary. Brother.
What?
The option is wrong. This option is wrong.
Right. What is the answer?
Custom USD attributes are different from custom prim metadata. The right answer is custom prim metadata, not custom USD attribute.
Metadata. Okay. So yeah, attributes are like properties, right?
Yeah, exactly. That's why I asked it twice. So USD, yeah, that's what I thought. Metadata, prim USD prim metadata. Hmm.
So it's going to be custom USD prim metadata. I see.
Yeah. What is the significance of prim paths in OpenUSD? They uniquely identify each object prim within the USD scene graph, right? They control level of detail. No, none of the above. They specify the order in which assets are loaded into the scene.
What is significance of prim paths? They uniquely identify each.
There's something. I think it's either going to be A or D.
They specify the order in which acid. Yeah, I think it's gonna be D. I would go with D.
It was A. I
They
knew it was A.
uniquely identify each prim object with
Let
USD.
me.
Let's verify once.
Absolute unique address is used to locate every individual, identify each object within a USD scene graph. Yeah. Bro, you're fucking. I don't know how your desktop audio is so loud. Why do I hear it so loud?
I don't know, bro. And why
I
not?
think it's because you're
Oh yeah,
because
I have fixed it. No worries. I think I fixed it.
it's because your mic is all there only where your
Yeah. Oh,
speaker is, I guess.
maybe. I think I need to add a noise cancellation on my system.
Yeah, see, again, every time you send a message, I just hear the fucking full thing.
Ooh, ooh.
Okay, so they uniquely identify each object within USD scene graph. Yeah, okay. Bro, specify the order in which. So this is loading order is not defined by prim path. Loading order is defined by I think composition arcs. Bro, why do you mute yourself and start
Loading,
saying?
order is by what?
I think composition arcs. Or what actually controls loading order? Sublayer composition hierarchy. Yes, composition hierarchy. Okay. A visual effects studio in USD is using USD to manage complex scene assemblies. There are experiencing issues with data duplication, that is same data being stored multiple times on different layers. Which of the following technique is most effective for reducing data duplication?
I know the answer for this. I think using instancing to share data between multiple prims. This will be
Using it to isolate different parts of the scene. Uh-huh. Okay, let's check. Yes, it's right.
not third time. Yes, third time was a charm. Maybe it was fourth or fifth. I have lost the count.
But we have to check this. What if it's wrong?
Let's check.
Bro. Oh yeah. Instanceable equal to true.
It said that the most efficient way, and that is the most efficient way. I would guess.
Composition arcs such as references or sublayers. Bro, this should be the right answer then. Using sublayers to organize prims into separate namespaces. Look.
No. It is talking about the most efficient way, right? So when you talk,
Bro, the most effective technique for reducing data duplication across different layers in an OpenUSD pipeline is using composition arcs such as references or sublayers.
wait, but combining. So the thing is,
Prim instancing. Oh, okay.
yeah,
Yeah.
yes, you took prim instancing. It's not
Oh,
gonna
okay,
work.
okay.
That is the main thing. So if you do instanceable false, it is still gonna create
Hmm.
memory buffers. But if you do instanceable true, it's not gonna create those.
Okay, 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 okay. You are working with USD stage that contains multiple layers. You need to determine the path to a specific prim relative to the root of the stage. With USD API method should you use get prim at path, get world matrix, get path, get type name on prim, get attribute, compute expanded, maybe A or C, right? Get prim at path, no, so get path, I think C. I think it should be C. Yes, it is C.
Which of the following is a common use case for variant
In
in
OpenUSD.
I think all of the above would be.
No, only B.
You sure? I think. Wow. Okay. Level of details can also be an answer as well, and managing different material assignments can also be an answer as well.
Yeah, yeah, you're right. I
Yes.
think. But we don't usually do level of detail using variant sets, right?
We
We've
are
got
not doing
a
it right now, but we are gonna do it few as we go more deeper. Like because this quiz is gonna take account of everything that is on OpenUSD, including wrong things as well.
mhm.
All right. 10 questions down, 10 to go. You have forest scenes with many trees to optimize performance. You want to instance the trees. What steps would you take? Yeah, A. I would go with A.
Yeah, it's a
Yeah.
standard instancing workflow, making a tree asset, marking it at as instanceable, and then referencing it multiple times. You want to create a material that supports both diffuse and specular reflections in US. I don't think we have done this. Shader. We have not done shader, right?
No. But I think the answer would be preview surface. Uniform mirror, that's
Yeah.
no,
Diffuse and
but
no, I think UV texture.
What was UV was 2D? Wait. Would you want to get another solid factor?
It's definitely not C because this is some geometry
Shade
thing.
shader and UV texture support. Oh yeah, I think it should be UV texture because I know the definition of UV texture thoroughly.
What is UV texture?
So UV texture is like basically you can have multiple points a comma b or x comma y on the mesh, and
Hmm.
on those points you can create different kind of materials accordingly. That was
Hmm.
so. Let's say you have a big mesh material, and you are putting some kind of prim in that point, and you can basically isolate it. Then you can have another coordinate x1, x2, comma y2 as UV, and you can also isolate that point. So based on the,
Mm-hmm.
yeah, I would say you want to create a material that supports both diffuse and spectacular reflection. And I think UV would be the most appropriate one. Let's see. No. UV surface.
But I think we should check this one
But the explanation that I gave is correct. Like that's how UV works.
for sure.
Yes. You can go back into the documentation and check as well.
USD preview surface. Yes, it's right. Node explicitly separates these two light interactions into dedicated input attributes.
UV.
Mm, correct. The shader support both diffuse specular reflections. Okay. What is the purpose of USD preview surface? What the hell? To provide physically accurate, no. Provide basic material definitions, quick preview, no. To create complex custom shader, no. Define lighting environments,
I
no.
thought, why is it no? USD preview surface. I think it should be C based on our earlier.
What custom shaders with advanced features?
Yes. To define lighting environment for the scene is gonna be for I think USD Lux. I would say.
Bro, this is.
Do defining lighting environment for a scene is USD.
Yeah, yeah, relax, relax. I know. Create complex custom. Physically accurate rendering material. Physically based rendering shading model built directly. Yeah, I think it's C. No, brother.
Provide a basic material definition for quick preview. What on USD preview? I think you should study USD preview and then I will come back. Dude, that's a different. See, the depth. You said, oh, 50% is in my ass. 50%. That's what I was saying. 50% ass. Me culo.
Power of compounding, you know.
Culo.
You're
All right, next one.
what is the primary purpose of USD schema definition system?
Is it D?
Uh, Structure of assets, right, data model. Optimize. What is the purpose of the USD shade input prim time?
No, stop.
Huh?
I'm not gonna answer this.
To define geometric properties of shade and input. What is so difficult in this? No.
Oh, sorry. That's why I was not gonna answer.
To
That is
define an input
different topic.
parameter for.
Not
Yeah, we
stuff.
have not done shader, right? That's why.
That's why I'm gonna skip every other question, and you can basically do any ballparking or any.
You are designing a USD pipeline for creating animated characters. You need to support facial rigging and blend shape animation, which appropriate approach is most suitable for representing the blend shapes. I don't know this.
No, no, don't know.
USD blend shaped API and define blend shape as attribute connections between our base mesh and
Wow,
right. Wow,
nice one.
bro. I think whatever answer we don't know, like whatever question we get confused in the exam for the certification, we should just use our instincts,
But
the
I think
tukka.
in the exam, the questions are not going to be like this. Once we go,
I know
we need to go through the other NVIDIA developer course, and then we will.
the videos.
Yes, yes. Because if he's saying that for the composition arcs, the questions are going to be like that. It's not difficult. But if the questions are going to be like tricky or more complex, or trying to test out your coding skills as well, like
Hmm.
looking at the code, what is the missing part, what's
Hmm.
wrong in this shader file, or what is wrong in this USDA file.
But I think if they give us the options, we'll be able to do it because
No, dude,
if you
the options are gonna be like that as well, like confusing AF. All right, next question. You have a large scene with many complex assets. You want to optimize scene for faster loading. What technique would be most appropriate? Payload, converting all assets, replacing, blah blah blah. Okay, yeah, that A would be the most appropriate one. Yes. Next one. You are developing a new render and want to integrate it with USD. What do you need to create? A custom USD shade material, a custom USD prim type, a custom USD file format. Okay.
custom Hydra delegate,
Yeah, I think that would be
because Hydra is the
render
mechanism.
delegator as well. Yeah, it's gonna delegate everything.
Yeah, I think that's yes,
Oh
yes,
yes. Oh
yes.
yes. Next.
You have USD stage representing a car model. The wheels are instances of prototype defined in a separate USD file. You need to change the tire tread.
Which is the most efficient way to achieve this? Edit prototype definition, edit the each will instance, create an order. Wait, what? Wait, but it is asking for the most efficient way.
Efficient way, like instead of going into the file for the instanced file, you can just do it in the root file by adding an override.
You sure?
I'm not sure.
No,
I'm obviously
actually,
not
override
sure.
won't be an answer because override is a specializer and that is the least one. So variant set live ups. So variant set it would be the most efficient way I would say that you can create a variant set of it and then do that because other
Oh yeah.
yeah right that would be my analogy over here. Like
Hmm.
doesn't make sense and then none of the above and then edit prototype definition. Because if you do override then if looking at the verbs, right? So li, so first is local, so whatever changes are in the local and that option is not given over here, so that's why I'm going with variance set. That is my suppose argument for going with variance set. Otherwise
The
override,
local opinion you're
yes,
saying.
local opinion would be the most appropriate way.
Bro, look at this. Override the tire tread pattern on the root prim of the stage, on the root. So that is going to be a local opinion.
But override is a specifier.
But override, bro, override. So that
Yeah, okay, okay.
it's in the
Yes,
first.
it's gonna be override then. Yeah, it's gonna be override.
Let's see. I can be wrong also. I think create new material and
Okay,
apply
but
to.
on the root prim of the stage. Okay.
Oh, I did the prototype
So I
definition in
think
the separate user.
let's go take a look. Let's give it to Gemini. I think we this could be a wrong one. Buoy. Because like based on the explanation that in the video,
Yeah, I did know that right. That's right. I did the prototype definition in the US separate USD file.
where did we learn? I think I never saw this. Like I did the prototype definition in the separate USD file.
I did the master pro. No, but we are right. Oh, bro, we are right. This is the right answer.
Right?
Look
Oh,
at this. The most efficient way to change the tire tread pattern blah, simultaneously edit the master prototype file directly or author a
I know.
single sublayer
Because that's what that
override.
told us that Yes, we are right, dude. It's
No, no, no. It's saying no. I
but
asked it if this is right, and let me ask.
dude, I no, I don't think so. Like, where did we saw this? Like, open Gemini in the Learn Open USD.
No, no, that is right. The answer is right over here.
Can
Exactly.
you
Editing prototype.
can you show the? Can you ask him to show the source? Like, I want to see where does it say about this, because then
Show source.
wheels are instance of wait. Wait. What does the question says?
What you need to change the tire, bro? Which is the most efficient way to do this?
The wheels are instance of a prototype defined in a separate USD file. The question itself says that. So the
Edit the prototype definition in the separate
yes.
USD file.
So based on the question, that's why we got it wrong. We have to read the questions thoroughly and focus on them. I think that's why we got it wrong. Because it's already instant somewhere, then we have to edit it.
Cause I'm bad. I'm bad. Mhm. The fuck happened over here? Okay.
Okay. 109. What is the purpose of a time sample in USD? To define material to camera. Yes, see. So like these easy questions are easy, but composition art questions are kind of tricky. Still. Last one. You have a USD stage with a complex material and defined with USD stage. You need to change the color of a specific shader. I quit. I'm not gonna answer this.
Okay. So yeah. Okay. So yeah, I think for tomorrow the goal would be to basically do that video over here that we were watching, and basically complete these 6 videos in the coming days. And
Like we have to work on the videos on our in our own time, and then
yeah,
yeah, because those videos are long and they're definitely getting us a lot of information. Like this cheat sheet is really important for us to understand the analogy.
yeah,
Yeah,
yeah.
I think I'm gonna go through more resources of NVIDIA Omniverse now.
Oh really?
Yes. Oh really?
Oh really?
All right, guys. Thanks for having us today.
Only two.
How many viewers we had?
We had 60 views today, but only two people are watching right now.
And the two that are watching us right away and right now.
Thank you for sticking around. We
Yes.
appreciate it.
Yes.
We're gonna be back tomorrow because we don't have any social life. And
Our only life is
yeah,
right now open USD certification. Gold.
Cloud code,
Lord,
Lord code.
Lord God, okay. Dude, I found, dude, that thing works super awesome. In $40, unlimited tokens.
What? What did you find?
I will send you on a message.
Okay.
Yeah. All right. Peace out.
Peace out, motherfuckers. End stream.